Properties of logs. There are three important properties of logarithmic functions that we can use to simplify problems and make them work better for us. And these three properties are, and it doesn't matter what base we're in, so I'm just going to write out log. So log of A times B is log A plus log B. The second one is log of A divided by B is log A minus log B. And log of A to the B is B log A. And these work both ways. So if we have A times B inside the log, we can split it up into two separate logs if that's more useful for us. Or if we have two separate logs, we can combine it into a single one as well if that's more useful to us. So we're going to use these in both directions for the purposes that we need them for. Okay, so let's look at some examples here. Okay, so say we have this expression. So natural log of 4 plus natural log of 3. And remember, natural log is just log base e. And most of the time in calculus, we're going to be using our logs base e. But in this case, we have two separate logs that are added together. We can combine these into a single one by doing 4 times 3. And so this ends up being natural log of 12. We can apply the same properties to something that's a little bit more complicated here. Now, notice here we have this coefficient of 3. Well, that 3 can move inside to become an exponent, and the same with this half. So this is going to equal log x to the third plus log x plus 1 to the 1/2. But now because these two logs are added together, that means we're multiplying all of these. So this is going to be log x cubed x plus 1 to the 1/2. Typically when we're trying to solve equations, we want to combine them together like this, because then if we have a single log, we can then solve for it. When we're doing calculus, usually though, we kind of want to split them apart. So for example, if we have, say, log of x squared y to the 4th, first off, we can split this up into two separate logs. And then once we've done that, those exponents can come out and become coefficients. And we end up with this. We can split up even more complicated expressions. For instance, if we have natural log of a to the third, b to the 7th over cube root of c, we can split these up. The two on top are going to have positive coefficients because that's a to the positive 3. The c on the bottom is going to have a negative coefficient because it's in the denominator, and when an expression is in the denominator, it's equivalent to having a negative exponent. So what we can do here is first we can split this up. Like this. So the a and the b are in the numerator, so they both have positive coefficients. The c is in the denominator, so it has a negative coefficient. And so now this is going to be 3 natural log of a plus 7 natural log of b minus Now, remember that cube root of c is the same as c to the 1/3. So this is going to be 1/3 natural log of c. Now there's one more property that we're going to use, and this is the change of base formula. And it says that log base a of x equals log base b of x over log base b of a. Okay, so if we start with something that's in base a, we can switch it to base b by the numerator is the log of what we originally started with. The denominator is the log of the previous base. For example, if we have log base 2 of 7, and we want to convert this into, say, log base 10, we can do log 7 over log 2. And remember, if there's no base listed, it's assumed to be log base 10. Or if we have log base 3 of x squared, and we want to convert this into base e, then this would just be natural log of x squared over natural log of 3.